Minimax M3 costs 0.60 per million input tokens, which is about 5% of what Claude Opus 4.8 charges. That's the number that stopped me cold when I pulled up the pricing page next to the SWE Bench Pro score of 59.0%. Minimax M3 just dropped as an open weight model with a million token context, and people are already building on it. So I went through all 5 of its boldest marketing claims to see which ones actually hold up, using verified sources, published benchmarks, and community reports with no vendor money and no cherry picking. The result honestly surprised me. 2 claims genuinely hold up, 2 I couldn't verify at all, and 1 is just flat out wrong in a way that could seriously wreck your deployment plan if you don't catch it first. So who's actually deciding whether to adopt Minimax M3 right now? Developers looking to cut API costs, teams processing long documents at scale, anyone who wants to self-host an open-weight model without paying for proprietary access. If the claims are real, you save a ton of money. If they're not, you build on a foundation that cracks the moment you push it past the demo. Claim 1, Minimax M3, can process long documents, handling 10,000 plus tokens without losing context. If this breaks, you're looking at a model that hallucinates details from earlier in the document, gives you summaries that contradict the source, and forces you to re-chunk everything manually, which adds up to hours of wasted engineering work every single time you hit the limit. The raw window size is real. The official API supports up to 1 million tokens, with a guaranteed minimum of 512K, verified straight from the vendor docs. The caveat you'll see on screen, though, is that coherence at long context is unverified. Minimax says their sparse attention architecture maintains quality, but there's no independent third-party test to back that up yet. I was expecting this to be a half-baked marketing number, and the window size is actually there, so Claim 1 delivers on the raw capability. Quality at the far end of that window is still a vendor promise with no independent proof behind it, but the core number checks out. 1 for 1 on claims holding up, though I'd treat the coherence part as unproven until someone runs an independent test. Claim 2, Minimax M3, costs way less than GPT-4 or Claude and still delivers comparable quality. If this is hype, you swap your production pipeline to the cheaper model. Your output quality tanks, and you spend weeks diagnosing why your results got worse before you trace it back to the model swap, which is a real cost, not a hypothetical one. On screen, you can see the full pricing breakdown. 0.60 per million dash for Minimax M3 versus 6.50 for GPT 5.5 and $5 ODASH for Claude Opus 4.8 on input, with output tokens at 2.40 versus 39 ODASH and 25 TONUDA respectively, and that's not a small gap. On code quality, Minimax M3 scores 59.0% on SWE Bench Pro, which is solid, but the claim that it outperforms GPT 5.5 can't be verified because there's no published GPT 5.5 score to compare against. I was expecting maybe a 2 times price difference, and the actual gap came out closer to 10 to 20 times cheaper on output tokens, which is kind of wild. The pricing claim delivers hard. The quality comparison to GPT 5.5 stays unverified, but the cost gap alone is enough to call this one 2 for 2 on claims holding up so far. Claim 3, Minimax M3 handles Chinese better than other open source models. If you're building a product for Chinese-speaking users and this claim is wrong, you're shipping mistranslations, losing customer trust, and paying to fix errors that a better tested model would have caught. And picking the wrong multilingual model for a production app is not a cheap mistake. I went looking for any published figure, any benchmark, any community test that would back this up, and basically nothing came back. On screen you'll see Chinese language accuracy, no sourced data available. There's some anecdotal community sentiment suggesting it might be decent, but I can't verify that. And without actual test results, this claim is just empty. I was expecting at least a community benchmark or a blog post with numbers, and total silence from the data is all I found. So this claim is partially true at best, meaning it might be real, but nobody's proven it. That drops us to 2 solid claims out of 3, with 1 sitting unverified, so take it with a grain of salt if Chinese accuracy matters to your workflow. Claim 4, Minimax M3 runs 2 to 3 times faster than larger proprietary models. If you're building a real-time app or a high-throughput pipeline, and this claim is wrong, your latency numbers blow up, your user experience suffers, and you've architected around a speed advantage that doesn't exist, which is the kind of assumption that costs you a full sprint to unwind. Minimax's sparse attention architecture does give 15.6 times faster decoding internally compared to standard attention. and that's a real internal number. But end-to-end latency versus GPT-4 or Claude. No published comparison exists. The 2 to 3 times faster claim looks like a misread of that internal speedup, not an actual head-to-head benchmark. I was expecting at least one real latency test, and a marketing number borrowed from an internal architecture metric is all that turned up. So this one's partially true at best. The internal speedup is real, the external comparison isn't backed up, and that puts us at 2 verified claims out of 4 with 2 unverified. The speed claim doesn't hold up on its own. Claim 5, Minimax M3 runs on consumer-grade hardware. If you believe this and plan a local deployment, you order the wrong server, set up the wrong infrastructure, and hit a wall the moment you try to actually load the model, which means real money wasted on hardware that can't do the job before you've written a single line of application code. Looking at the actual memory requirements from Unsloth's documentation, the lightest quantization, the 1-bit GGUF version, needs at least 133 gigabytes of combined RAM and VRAM, and most consumer PCs have 16 to 64 gigabytes. The full table on screen shows 3-bit needs 159 GB, 4-bit needs 213 to 270 GB, and 8-bit needs 460 to 470 GB. So that's not a laptop, that's a data center. I was expecting it to be tight, maybe needing a high-end workstation, and 133 GB minimum is what the docs actually show, which is enterprise hardware, full stop. This claim falls short and it's not even close, so the final tally is 2 of 5 claims hold up, 2 are unverified, and this one is just wrong. For most people, the API is the only real way to run Minimax M3. Alright, so where does Minimax M3 genuinely shine? The context window is real, up to 1 million tokens, verified in the API docs. The pricing is absurdly good at 0.60 per million input tokens, which is about 5 to 10% of Claude Opus 4.8's price, with a SWE Bench Pro score of 59.0%, backing up the quality side, and its open weight at 428 billion parameters, so you can fine-tune it if you have the hardware. Now, where Minimax M3 falls short, the Chinese language superiority claim has 0 supporting data. The 2 to 3 times speed advantage over proprietary models isn't backed by any end-to-end test. Self-hosting needs 133 gigabytes of RAM at minimum, which rules out basically every consumer setup, and there's no published training data breakdown or long-term update roadmap from Minimax. Honestly, I went in expecting a budget model with obvious compromises, and the cost gap genuinely shocked me. 2 claims hold up, 2 don't have enough data to call, and 1 is flat wrong. So here's the decision rule. Use Minimax M3 via API if you need a huge context window and the lowest possible token cost, because 5% of Claude's price is real. Skip it if you need verified multilingual accuracy, proven speed benchmarks, or any kind of local consumer deployment.